there. But maybe let's start from the very beginning of the story. All that started, I'm working for Merging Technologies in Switzerland. It's a company who started 35 years ago. I joined, I co-created in '92 this company with Claude Cellier, a guy who worked 10 years for Nagra originally. He was designing the T-audio and tape machines for Nagra for many years. Then funded Merging Technologies in '90. We registered the company in '93. I joined in '92 when it was all starting. And we've been designing ADDA conversion. It's professional products heading on the recording and mixing and production area. We've been designing a very successful digital audio workstation that is still in use today for high-resolution recording. This is a product that led us going to the depth of high resolution, high number of tracks, high quality conversion, AD and DA, and we've been at the top of high quality recording, as opposed to other workstations that were more designed for mainstream music. We have been always concentrating on classical music, jazz music, all those very demanding in audio quality. And this is why in '99, when Sony and Philips started the SACD project, Sony created the DSD format, digital stream, direct stream digital, in '98, we had the first discussion in '99 with Sony. And they needed at this point a workstation to create content, to actually record and create the content for SACD. So we've been in contact very early with Sony and Philips to create tools for this high-resolution recording. At this stage, Sony embarked with the founder of Playback Design, Andreas Koch, and they created a workstation called Sonoma that was able to record DSD content for the SACDs. We embarked with Philips at the same time, and we adapted our existing workstation, Pyramix, to record DSD material. And we created at this point the DXD format. The DXD format, which still exists today, is in fact PCM at 8 times the speed of 44.1. It's a 352.8 kilohertz. It's a very high speed PCM, basically. That together with the Philips engineers and mathematicians, we decided to go this route because this allowed at that time and still now to process audio and to edit, mix, EQ, and do all the audio processing needed for post-production in recording. Some purists of DSD would like to use only DSD and keep a DSD stream pure, which is very difficult for real live productions. It's very DSD, and you will see after why we're DSD fanatics, is a wonderful format as far as capture and transmission and conversion is concerned. It's a perfect format. But for production, it's a very difficult format because it adds a lot of high frequency noise in the signal as soon as you do some processing in the signal. So we've opted for the DSD route with Philips and created a set of tools that is today the only remaining workstation able to record DSD worldwide. At the end of the SACD project, basically MP3 won. The year the SACD project came to market, Steve Jobs came with the iPod, and basically Steve Jobs killed the SACD. As such, convenience and portability won over quality at that time. So unfortunately, SACD had a very short life. However, DSD still exists. It is still a highly appreciated format in terms of recording and preserving audio. So the workstation we're doing at Merging is still the tool of choice for DSD producers. And that's a tool that still exists and is maintained. Now, in 2012, so 12 years after this SACD project started, we decided at Merging with a partner of us based in Vancouver, Canada. We thought that our converter were used, and because of the SACD project being multi-channel, we had a lot of customers that needed a multi-channel DAC. So they came to us at Merging and they started buying our professional converters for multi-channel purpose. And they were immediately puzzled by the complexity and the ergonomic, and it's really geek tools for professionals. So we decided at this stage with our partner in Canada, Mr. Shu, to create an audiophile version of our converters at Merging Switzerland. And we started a company called Master Fidelity that is based in Canada to ease the process of entering the audiophile market with the Swiss-based converters. So at this point, Merging Switzerland created a complete range of audiophile products, and this is the NADAC, the foundation of the NADAC converters that was created at that time. It was made in Switzerland. This is the first unit, is the DAC itself. It's based on the professional DAC we had, but with all the audiophile standards, a proper chassis, a proper power supply, a proper integration and ease of use, and proper drivers and everything. Soon after, we introduced the player, the Merging player, where we put a computer inside, able to run a server. And we were, at that time, the first unit that integrated a Roon server, a Roon core, because we were friends with Roon even before they were called Roon. At the Meridian time, we knew this team already. And we were actually the first product integrating a Roon core into. Then, by the time expanded, so these two products were made in Switzerland by the Merging Technologies team. And then the Vancouver team started helping us in Switzerland by adding the clock and the power component. Because this team in Canada is ultra specialized in clock, in measurement equipment, in very high precision and clocking devices. So this team in Canada helped us and designed for us in Switzerland those two units. it happened, and this product has been selling well and was well deployed worldwide through a set of distribution separate from the professional field that we're still running at Merging Swiss. And in 2022, Merging Technologies has been acquired by the Sennheiser group in Germany. And at that time, Sennheiser was just selling off his own consumer department the year before to concentrate on professional products. So in 22, when we joined the Sennheiser group, the consumer product, the NADAC branch, has been discontinued by Sennheiser. So the Canadian entity based in Vancouver decided to take over the complete consumer product because of their experience in high resolution, in clocking and all that, and create a renamed Merging Fidelity into Master Fidelity. So the foundation of Master Fidelity is 22 in Vancouver. It's now a Canadian-based company. But that is composed of the same team that was already running Merging Fidelity since 10 years, since 2012, basically. So now it's completely two separate companies. I'm personally still working with Merging Technologies in Switzerland, and I'm in the Sennheiser group doing all the professional side of equipment. So I'm a software guy myself. So I'm the designer of the workstation and all the production tools for DSD and PCM and all the professional recording equipment. And the Canadian team, Master Fidelity, is now renewing his complete range through this new equipment. So this gave the opportunity to create from scratch a completely new range of products based on their experience. So basically the clock, and we're going to there, is completely inherited from the Merging clock. And it's the same technology inside that is now grown to even more precise and more sensitive crystals inside, but it's based on the same technology, while the DAC is a completely new technology. On the Merging side, the DAC that we had before was based on totally professional technologies. It's the same DAC that we're using in our professional equipment for recording and monitoring and mastering, using traditional technologies, basically ESS chip converters, where in the Master Fidelity, it's a completely new story that has been created here that I'm going to elaborate a bit here. So all that led to the discontinuing of the Merging NADAC product and transferring all these assets to the Master Fidelity Canada-based company. And this leads to this new company and these new products here. So this DAC is now entirely done in Canada and is based on a new technology, not that new, called the True One Bit, which has at the heart of the True One Bit is a DSD signal. So as I mentioned before, at Merging Swiss, we always believed that the XD and very high resolution PCM was the way to go for production and post-production, especially for editing, mixing, processing, because there was requirement of processing. When you do a transfer from tape to file, a pure DSD conversion is fine. But as soon as you need to record an orchestra, a symphony, an opera, and you have to do some editing, processing, you record, typically our customers using the workstation, when they do any production, typically Deutsche Grammophon is one of our very old customer. They have made more than 250 productions with our tool. When they do a recording, they generally record multiple events, and they cut that together. They take the best part of it. They assemble all that. They edit. It's thousands of edits for one opera typically, and then there is a mixing process and a mastering process, and it has to be delivered in multiple formats. In DSD, of course, but also in PCM, in all the FLAC, in streaming format. The delivery format is huge. Now we have Atmos coming, and it delivers now to platforms like Apple Music, like Universal's, all kind of streaming, Qobuz, Tidal, whatever. So our customers at Merging, when they do a production, they deliver like 20 different deliverables. It's a huge process, and doing that in DSD is just impossible. So the pure professional direction going PCM is the correct choice that we did at Merging in terms of production. Now, in terms of conversion, the choice that Master Fidelity did is, to me, the obvious correct choice is that a DSD stream is absolutely the closest thing existing to analog in terms of digital. And especially now that we reach DSD 56 or even 512, we're entering in a digital signal that is the closest possible to analog structurally itself as such. And the decision here has been made to create a DAC that takes in input a DSD 256 or 512 signal and convert it directly to analog from there. Philips has done that 40 years ago with a chip called, now, let me remember the name, it's the TDA 1547. 40 years ago, when they started creating the SACD project and the DSD format, they created a chip that was converting, that was already a true 1-bit chip, converting DSD 64 to analog. And this is one of the best sounding chip ever created in terms of conversion. It's just happened that it's very costly, and nobody could afford doing. If the SACD had been successful and had continued, they would probably have other versions of these kind of chip done by Philips or Sony or other manufacturers. It's just happened that with the end of the SACD format, delivery format, DSD remained purely a streaming format or a file download format. And the industry stopped investing in that. So some company created 1-bit chip or 1-bit converters using FPGAs or ladder technology or this kind. It's a good solution using an FPGA. The problem intrinsically of FPGAs is that there's a lot of jitter inside. This is a generic hardware chip that is able to do many different things, that is programmable by nature. It's a FPGA, field array, programmable array. But the problem is the jitter. It's quite a poor clock internally. So chief engineer of Master Fidelity decided, because of today, we have reached a point in technology where creating our own chip, an ASIC, ourselves, is possible technologically, and is not that expensive anymore. It's still very expensive as compared as programming an FPGA, but it's in the realm of reasonably possible. So what they've done is that they've created their own chip. This is the equivalent, or in the same philosophy as the original Philips chip, but going up to DSD 512, today's range of throughput of bandwidth, and it's a chip made in Taiwan that we have designed. Master Fidelity has designed and has produced, and that we own, and that is completely unique. That creates the foundation of Master Fidelity and the NADAC D, is this native true 1-bit technology, and native means incarnated in our own chip. The advantages of true 1-bit is that it's got an ideal linearity, where other technologies like multi-bit or ladder or whatever other have a quite poor linearity. And that is at the heart of the sound of NADAC D, is that you clearly hear the reality. The content of the signal in the DSD is transferred to analog as if it were already analog, basically. That there's no lost or jitter introduced in the conversion. Now, this comes at a cost, because true 1-bit is extremely demanding in terms of technology. It requires an extremely high precision clock. It requires very, very low jitter. It also requires very, very low wander. I can explain later, and we have in the FAQ of Master Fidelity, there is some explanation between this. We can discuss that when I present the NADAC C, the clock. But basically, a true 1-bit DAC, in order to work properly, requires a very high precision clock, and also a very stable power supply. So this is why the NADAC D has its own high precision clock inside, and it's also got an extremely precise recovery clock in order to accommodate with incoming signal. Like if you clock on an AES input, it has to be basically realigning, refiltering the incoming clock signal. There's clock, how we say that? Power, oven controlled power supply, sorry, I'm confused, to ensure that the power supply feeding the chip is also ultra stable. So these are the oven controlled power supply. That was also one of the challenges required. We have this recovery clock system that I mentioned here. So if we're having an USB input, the internal clock of the NADAC is used. It's a very high precision clock. If we have an AES or an optical coaxial SPDIF input, this we have to use the external clock, but we have to recover it in order to be stable enough to feed the true 1-bit chip. doing all that, because of this USB requirement of clocking, we had to design our own USB solution. We use the Amareno drivers and software, but on our own driver, own hardware. So here also we had to design our own USB solution. And here, well, there's a few things you're happy to read on the website, but that creates the foundation of the NADAC D here. We've chosen, and this is still a challenge here, we decided to go with USB-C because it's future-oriented, but also to deal with this amount of throughput. USB-C allows for much better quality of USB signal. And this is a challenge because the entire audiophile world is based on USB-A. All the cable manufacturers, all the existing equipment and cables have to be adapted. So for this, we acknowledge that after 2 years, this has created some issues. We're coming with our own cable. That took 1 year to design to go to these high rates. Because there are a lot of USB cable, but not all of them go properly up to DSD-512. It's pretty challenging. So we've designed our own USB cable and an adapter, our own design adapter for using traditional USB-A cables. Of course, a clock input. And here, there's all our specifications. I will not bother you with that here. So you can go and check in detail what the DAC is able